integrating terms of the form x to the power of n. Integration is the reverse process of differentiation. And we looked at differentiation where in order to differentiate x to the power of n, we multiply the coefficient by the power and then we subtract 1 from the power, resulting in this here. So since integration is the reverse of differentiation, we will completely reverse this process. So instead of multiplying by the power and subtracting 1 from the power, we will add 1 to the power first and then divide by the new power. So this then leads us to get the standard result for integrating. So one thing to note though is that if we were to differentiate y equals x squared plus 5, we get 2x. If we were to differentiate y equals x squared, we also get 2x. And if we were to differentiate y equals x squared minus 19, we get 2x. So when we integrate and we do the reverse of this, we will obviously add 1 to the power, which becomes x squared, and divide by the new power 2, getting us y is equal to x squared again. But then that alone itself is not enough, because we saw that certain terms, the certain expressions that we differentiated actually had another term, a constant term, plus 5 or minus 19, or in this case, plus 0. But this would be forgotten about if we just integrate. So we need to take into account this. So we say add c, a constant of integration. So when we are integrating, we should always add a constant term here. And this is true for all indefinite integrals. So here is the process of integrating. So when we have something which is of the form x to the n, when we integrate that, we add 1 to the power, so it becomes n plus 1. And then we divide by the new power, n plus 1, and we add c, the constant of integration. Let's apply that to this particular example here. So to begin with, we're given the curve with equation y is equal to f of x, and it passes through the point 45. Now we don't know what this curve, what the actual equation is, but what it does give us is it does give us f dashed x, which is the gradient function of that particular curve. So we need to go back from this gradient function, and what we're trying to do is we're trying to find the equation of c, i.e. we're trying to find out what f of x is. So let's start by writing down what we're given. F dashed of x is equal to x squared minus 2 over square root of x. And we want to find out what f of x is, which is the equation of c. So let's first of all write this out in terms of indice form, get it into a form where it's actually in the form of x to the power of something, so we can integrate it. So we get x squared minus 2 all over x to the power of a half, which if we then divide each term by x to the power of half, we get x to the power of 3 over 2 for the first term, and then minus 2 over x to the power of half becomes minus 2 x to the power of minus a half. We still haven't integrated. This is still f dashed of x. We are going to now integrate this. So f of x is the integral of x to the power of 3 over 2 minus 2x to the power of minus a half. And we're integrating with respect to x. So when we integrate this, we add 1 to the power. So there's the power 3 over 2. We are going to add 1 to the power, so it becomes x to the power of 5 over 2, and then we divide by the new power. Likewise again, we've got this 2x, add 1 to the power, so minus half add 1 becomes a half, divide by the new power, plus the constant of integration. So now that we've integrated, this is f of x. Let's go and tidy this up a bit. So we've got division by 5 over 2, which is the same as 2/5 of x to the power of 5 over 2. And this becomes minus 4 x to the power of a half plus c. Now we were given another piece of information here. We knew that f of x passes through the point 4, 5, i.e. the x coordinate is 4 and the y coordinate is 5. And here we've got an equation y is equal to f of x. So if you think about it, we can rewrite this y is equal to f of x in terms of y is equal to 2/5 x to the power of 5 over 2 minus 4 x to the power of a half plus c. Substitute our coordinates x and y in to find out what this constant of integration is. So the y value is 5 is equal to 2 over 5. The x value is 4, so 4 to the power of 5 over 2 minus 4 to the power of a half plus c. So if we find out what this gets us then, so we've got here 5 is equal to 2/5 of 32 minus 4 lots of 2 plus c. So this then gets us 64 over 5 minus 8 plus c is equal to 5. And then if we rearrange that and make c the subject, we get c is equal to 1/5. So we found the constant of integration. Let's go and rewrite our f of x, what the equation is. F of x is equal to 2/5 x to the power of 5 over 2 minus 4 x to the power of a half, and the c value was plus 1/5.